Welcome to this explainer. Today, we're going to dive into a pretty wild narrative. It's really a story about the intersection of two totally different worlds of technology. On one side, we've got the cutting-edge, completely mind-bending realm of quantum physics. And on the other, the gritty, power-hungry, globally decentralized world of cryptocurrency mining. It's a tale of massive inefficiency for sure, but also about a totally ingenious technological solution. Let's get into it.
Nature isn't classical, damn it. And if you want to make a simulation of nature, you better make it quantum mechanical. That bold, kind of perfectly frustrated statement was made by the legendary physicist Richard P. Feynman way back in 1982, and it really hooks us right into the core of our story today. Because long before we even try to define what a, quote, qubit actually is, we have to grasp this fundamental truth. To truly simulate and understand the universe, our computers need to actually speak the universe's native quantum language.
So let's start by looking at what we're calling the global compute paradox. Right now, we are living kind of awkwardly between two distinct tech extremes. Picture this. On one hand, you have these billion-dollar quantum research labs. The machines they're building in there are incredibly fragile, they require teams of highly specialized researchers, and, get this, temperatures that are literally colder than outer space just to function. It's a very elite, highly controlled, and freezing cold world. But then, on the other hand, you have the hot, buzzing, widely accessible world of standard computers and graphics processing units, GPUs, scattered all over the globe. Right this second, millions of highly capable GPUs are just sitting idle. We're talking about a massive, staggering amount of general-purpose compute power just gathering digital dust, waiting for something to do. And, the paradox gets even deeper when we look at the GPUs that are actually doing something. Massive warehouse-scale farms of them are out there spending enormous amounts of real-world electricity just grinding away at cryptographic hash puzzles. And their only purpose? Securing a blockchain. It's basically a relentless digital treadmill of static, repetitive hash generation. The sheer scale of global energy consumption poured into these static puzzles is honestly mind-blowing. So we end up in this weird situation where elite quantum computers are struggling to scale up, while incredible raw computational power in the classical world is either totally asleep or burning massive energy on pure repetition.
All right, let's break down the underlying science a bit. Bits, qubits, and coins. To really understand how we can bridge this massive gap, we need to explore why quantum computing is just fundamentally different from the classical tech you and I use every day. Traditional computers process information using bits, right? And those are locked into being either a 0 or a 1. Every video game, every machine learning model eventually boils down to sequences of these super rigid binary operations. Quantum computers, though, they use qubits. And unlike classical bits, qubits can exist in multiple states simultaneously. This is a property known as superposition. Think of a spinning coin. While it's spinning in the air, it isn't simply heads or tails, is it? It exists in this dynamic, blurry combination of both states until it finally stops and you look at it.
But the real magic, that happens with a concept called entanglement. When qubits become entangled, the state of one becomes directly connected to the state of another, no matter how far apart they are physically. I know, it sounds straight out of science fiction, but this specific property is exactly what allows quantum systems to solve certain classes of incredibly complex problems way more efficiently than our standard computers ever could.
Which brings us to the crucial need for simulating the quantum world. Here's the rub. Despite all this incredible potential, modern physical quantum hardware is still extremely limited. Today's systems operate with very few qubits, and they are incredibly sensitive to background noise and something called decoherence. Basically, perfect hardware is still years away. Because of this extreme fragility, scientists desperately rely on classical simulation to build a bridge to the future. Researchers actually use standard, classical hardware to mimic the behavior of quantum systems. This lets them test out new quantum algorithms, study deep optimization problems, experiment with new circuit architectures, and basically lay all the necessary groundwork so we're ready when that flawless hardware finally does arrive. But, as you might guess, there is a massive catch. As these quantum systems scale up, as we add more of those spinning coin qubits to our models, the complexity of simulating them doesn't just grow step by step, it explodes exponentially. Quantum simulation relies heavily on really dense linear algebra and tensor operations, and our traditional computers, they practically choke on these operations as they scale up. Trying to run these complex models on classical hardware just becomes wildly, prohibitively expensive really fast. And that brings us right back to our original paradox. We've got these incredibly expensive quantum simulation bottlenecks, and at the exact same time, millions of GPUs around the world are either sitting totally idle or burning electricity on static blockchain puzzles. So the absolute crucial question, and really the pivot point of our whole story today, is this. What if all this global compute power actually had a purpose?
Enter quantum proof of work. So let's look at Qubitcoin and this concept of quantum proof of work, or QPOW. Traditional proof of work just asks miners to repeatedly generate hashes until they stumble on a valid solution. It's a pure brute force numbers game, right? But QPOW integrates actual quantum simulation workloads directly into the mining process itself. It adds a whole new layer, quantum circuit simulation. And what's brilliant here is that it preserves that rock-solid blockchain security by tying transactions to unpredictable parameters, but it completely redirects all those GPUs toward real, meaningful scientific research. And this perfectly illustrates what's going on under the hood. A quantum circuit is essentially a blueprint for a quantum computation. It maps out the qubits, the gates that manipulate them, how they interact, and the final measurements. So when GPUs are out there mining Qubitcoin, they aren't just guessing random numbers anymore. They are actively executing simulations of these specific quantum circuits. And the coolest part? GPUs are uniquely, perfectly suited for this because they're already designed to perform enormous numbers of simultaneous calculations to render video game graphics. Their architecture is just a flawless match for the intense linear algebra required by these quantum simulations.
So, what does the future of useful compute look like on a global scale?
Look, one GPU on its own is obviously pretty limited, but thousands and thousands of GPUs coordinated on a decentralized network, now that is a monumental shift. And the scope goes way beyond just quantum simulation. Most proof-of-work systems just optimize for hash generation, but we are looking at a future that moves far beyond static hashing. We're talking complex simulation, optimization, machine learning, and other incredibly dense scientific workloads. There are even architectures emerging, like super-dense consensus or SDC, that push this vision even further. They're exploring multi-workload systems that can coordinate different forms of programmable, useful computation all at exactly the same time. This kind of network completely removes the need to rely on elite, closed-door institutions or expensive tech monopolies. Anyone, anywhere, with capable hardware can actually contribute to science. It's democratizing access to vital infrastructure.
The infrastructure layer matters right now, today, long before we ever see perfect physical quantum hardware. Qubitcoin and QPOW are showing us a truly fascinating path forward, making us fundamentally rethink what global blockchains can actually achieve for the world. Which leaves us with this final, provocative thought. Could a decentralized proof-of-work network, a system previously known basically just for securing digital money, ultimately become the world's absolute largest open scientific engine?